Hi everyone, this is Trinadh Reddy. Welcome to Unacademy Live Gate. Here I have 18 years of teaching experience in the field of gate engineering services and public sector units, and I have been teaching analog electronic circuits, electronic devices and circuits, control systems and signals and systems. Now I would like to solve a problem on BJT biasing, which was asked in previous gate papers of electrical engineering. See this question. A transistor circuit shown uses a silicon with transistor with VBE of 0.7 volts. VBE of 0.7 volts and IC is equal to IE. Of course, they mentioned DC current gain beta of 100. Beta is 100 means generally we have a practice of taking IC is equal to IE. Okay, that's valid. And the value of V output is, here there is a small error, right? The value of V output means this is our V output. Voltage at the emitter of the transistor, this resistance, emitter resistance is 100 ohms. They are asking us to find V output. It looks like a very simple problem, no doubt about it, but there is some point to be observed in this. How to do this problem? See this. Then I am redrawing the circuit. Volts, 10 kilo ohm, 50 kilo ohm, 100 ohms. Then let us take various voltages. It is VBE, base to emitter voltage. Current entering the base is IB. Current entering the collector of transistor is IC. So that this current is IE, that is IB plus IC. We can take it. This is IE. They mentioned beta is 100 and IC can be approximated to IE. Let it be. Then let us find the values. If I take this as some input loop, of course they are asking us to find V output. Okay, let us take this loop. Here it is 10 volts is equal to IB into 10K plus VBE plus IB plus IC into 100 ohms we can take. So if I take the input loop equation, input loop implies 10 volts is equal to IB into 10K plus VBE plus IB plus IC into 100 ohms. So we know that IC is equal to beta IB, and rearranging we can directly write IB is equal to 10 minus VBE 0.7 volts by it is 10 kilo ohm plus 1 plus beta, it is 101 into 100 ohms. If you solve it, you will get it around 0.467 milliampere. It is around 9.3 by 20.1, 91 by 21, you will get it around 0.467 milliampere. What about IC? IC is equal to beta IB is equal to 100 into 0.467, it is equal to 46.7 milliampere. Okay. Once you get IB and IC, what is V output? IB plus IC into RE, or V output is equal to IB plus IC into 100 ohms RE. It is equal to 0.467 plus 46.7 milli into 100 means it can be multiplied with 0.1. It has come here. Okay. So if you find its value, it comes to be around approximately 4.67, something like this, you will get it. Okay, which is close to our answer, which is close to the answer here. 4.65 volts, it looks like that, right? Remaining options are some 5 volts, 6.3, 7.23, like this. Okay, up to here it looks like, right, 4.65 volts is your answer. Okay, further, if you see one important point here, what is IC? We have got IC is equal to 46.7 milliampere. Then what about the voltage drop ICRC? If you see the voltage across RC, this voltage, if you take it so, right, ICRC value, if I consider ICRC, if I consider ICRC, how much do you get? It comes around 46.7 milliampere into 50 kilo ohm. So how much do you get? It comes milli and kilo cancel. 46.5 means it is 2315 volts, you will get it. Is it possible to get this much voltage from 10 volts power supply? Really meaningless. Means IC cannot be equal to 46.7 milliampere. Definitely IC cannot be taken as beta IB. IC should be less than beta IB. Just see this. Okay, and no answer is possible. You see, if I assume IC is equal to IE, if I neglect IB also, IC is equal to IE. If IC is equal to IE, that value is, right, coming to be around 47.67. So if the total voltage is 4.67, then the current is 4.67 by 100, that is 46.7 milliampere. Right? If so, if you look at the previous remaining answers also, if you take 5 volts, 6.3 or 7.23, then 5 volts by 100 or 6.23 by 100 or 7.23 by 100, all the values are leading to a collector current from which ICRC is looking greater than 10 volts. Means no answer is matching. It looks like this answer matches, but that itself is also a wrong answer, because if you get IC to be, if you take IC is equal to 46.7 milliampere, ICRC if you take, that is exceeding the power supply. How do you get 2315 volts from 10 volts supply, which is against law of conservation of energy? So definitely IC cannot be this value. IC might be less than, IC should be less than beta IB. Means BJT might be in saturation as far as the circuit given is. You cannot even take IC is equal to 46.7 milliampere. Unfortunately, they gave the wrong data in this problem in previous gate papers. Okay. See this. So then what might be the values of IC and IB? Just out of curiosity, we are looking at those things. So let us take the same circuit and finding these things. IC is less than beta IB means such thing is possible only in saturation region. Once BJT is in saturation, then IC is less than beta IB or IC is less than alpha IE. We can take it. It is a 10 volts, 10 kilo ohm, 50 kilo ohm, 100 ohms. Okay. And here as IC is less than beta IB, which is possible only in saturation region. So what about the values of VBE saturation, VCE saturation? Means just I'm writing those values. Here it is VBE saturation, whose value is 0.8 volt it is VCE saturation. Its value is 0.2 volts. So what about our VCB? VCB is equal to minus 0.6 volts. We can take it. VCB is equal to its value is equal to minus 0.6 volts. I am taking like this, and I can mention the currents like this. This current should be IC saturation and this current is IB. I can take. IB. Its current, this current is IB plus IC saturation. We can take. That is our IE. This is V0. V0 cannot be taken as any one of the options given. Then what might be the V0 in the circuit given? Let us see this. So if I take this particular loop equation, IB into 10 kilo ohm is equal to IC saturation into 10K minus 0.6 volts. We can take it. So VCB, or even though I wrote it, just for our understanding purpose, I am erasing this, and this minus 0.6 volts I will be showing. It is 0.6 volts with polarities minus and plus. We can take like this. Now you take this loop equation. I am taking this loop equation. If I take this loop equation, what we can write is IB into 10K is equal to IC saturation into 50K minus 0.6 volts. So if I take that value, IB into 10 kilo ohm, it is equal to IC saturation into 50 kilo ohm minus 0.6 volts. So that I can write IC saturation in terms of IB as IB into 10 kilo ohm plus 0.6 by 50 kilo ohm. Okay, keep it aside. Then let us take this input loop equation. If I take this loop equation, as loop 1 or input loop, right? Input loop implies 10 volts is equal to IB into 10K plus VBE saturation, that is 0.8 volts, plus IB plus IC saturation into 100 ohms. We can take it. So 10 volts is equal to IB into 10 kilo ohm plus VBE saturation plus IB plus IC saturation into 100 ohms. Then in this I can write 10 minus VBE saturation, it is 0.8 is equal to IB into 10 kilo ohm plus IB plus, instead of IC saturation I can write IB into 10 kilo ohm plus 0.6 volts, 0.6 volts by 50 kilo ohm, the whole thing multiplied with 100. So I can solve for IB here. If I solve for IB, we will be getting 0.909 milliampere. This is the actual value of IB. And if you solve for IC saturation, if you substitute in this equation, you will be getting 0.193 milliampere. I am directly writing these values, you just cross check. Okay, we can take these two values. If so, what might be your V naught? According to that, if you take your V naught, it is equal to IB plus IC saturation into 100. It is found to be, if you substitute those two values, it comes around 0.11 volt. It is found to be 0.11 volt. This might be your answer as far as the circuit is given. Okay, let us cross check our loop and loop equations. You take either input loop equation or output loop equation. They should, the values of IB and IC saturation should satisfy the loop equations. Let us check that also. So, or here, if I take the input loop equation, 10 is equal to IB into 10K plus VBE saturation plus IB plus IC saturation into 100 ohms, that should be satisfied. Let us check it. Just I am considering, right, if I consider IB into 10 kilo ohm, just from the input loop I am writing, plus VBE saturation plus IB plus IC saturation into 100. If I consider this value, how much do you get for IB? How much we have got? It is 0.909 milliampere into 10 kilo ohm plus VBE saturation is 0.8 plus its value we have already seen, it is 0.11. If you add all these things, milli and kilo cancel, it is 9.09 plus 0.8 plus 0.11, it is equal to 10 volts. You can cross check that one. 100% it is satisfying our input loop equation. This is from input side I am taking. Similarly, consider this output side. If I consider the output loop equation, 10 volts should be equal to IC saturation into 50K plus VCE saturation plus V naught, that is IB plus IC saturation into 100 ohms. Let us check that also. That means again I am considering, if I consider output side, that is IC saturation into 50K plus VCE saturation plus IB plus IC saturation into 100. If I take these values, IC saturation, it is 0.193 milliampere into 50 kilo ohm plus VCE saturation, it is 0.2 plus its value is already found, it is 0.11. If you add all these things, you will get it also approximately 10 volts. You just cross check it. It is approximately 0.2 into 5. Here itself you can see almost it is coming close to 10. Right, of course, you just calculate all those things. It is satisfying the output loop equation as well. You see, it is not like commenting and all. It happens sometimes. They have not verified the data, and they give from the according to the given data, no answer is matching. Right, this is what you can see. You cannot take IC is equal to 46.5 milliampere or 46.7 milliampere. If you take it so, again and again I am mentioning that will ICRC is exceeding the power supply of 10 volts, which is against law of conservation of energy. Whatever the resistors and all you take it, voltage across RC and voltage across RE and VCE, some of these three voltages should be equal to the power supply from output side. The same thing you can take from input side as well. That should not deviate from law of conservation of energy. Okay, just to make you aware of this point, I took up this problem. Actually, it is a simple problem only, but unfortunately, they gave some wrong data in the given question. Okay, that is it. And after this, coming to our Unacademy Plus benefits. Okay, unlimited access. Okay, you have the you can access so many lectures by various faculty members. Right, it is not like only one time you can able to listen and later on you are not able to watch. There is no such thing, right? You can attend a particular faculty's class for a number of times. Not only that, so many other faculties with different examples you can see. And you need not worry about whether you are a college going student or working person, whoever it is, right? And this one, structured live courses. Structured live courses means as all the courses are going one by one, and you want to sometimes you may have to attend, if it is an offline course, you may be attending a course for which the prerequisite may not be done. But here you need not worry about it. First you can have a look at the videos of the prerequisite, the very basic level subject, next advanced version, so that your confidence is different from the other people, right? You can do with more confidence. These are the advantages you have with structured live courses. And top educators here, the faculty members are having a vast experience along with very good academic profiles and all. So these are the advantages you have with Unacademy Plus. And to attend my sections, right, next point is my upcoming course. As the GATE exam is coming close, right, I'm starting one course here on analog electronic circuits, which is further subdivided into 4 modules like diode applications, BJT, FET and op-amps. So first 2 modules I will be doing parallel. Once I complete these 2 sessions, I will be going to the next section of FET and operational amplifier simultaneously. Even though I have not mentioned, along with operational amplifiers, I will be dealing feedback amplifiers and oscillators as a part of this 4th module. That's about the course structure. And to subscribe to my course, just you can stay tuned with Unacademy and use the referral code TRK10 to avail 10% discount. And I wish you all the best. Thank you.